Hello guys, welcome back to our channel Insane Physics. This is Vamsi here at Insane Physics, and in a previous video we have discussed differentiation, right guys? Yes, I hope you have practiced some sums on it, and also we have discussed many sorts of equations on it, and yes, we have completed that differentiation. And in today's video we will be talking about the converse of differentiation, that is your integration. I have given you a small introduction to this integration in the previous episode of this AGNI series, that is your differentiation episode. I have that is also there. If you haven't watched it, I recommend like watching it. If you want, you can watch it, but there is no link between differentiation and integration, which I'm gonna tell today. I'll be revising these differentiation topics which I have already spoke in the previous session. Same in this session also. Sometimes wherever it is required, I'll be repeating these differentiation topics from the previous episode in today's episode. Okay guys, okay, this is Vamsi. If you're set and is everything good to go, yeah, let us start with today's topic of AGNI series 2024, that is your integration. This also comes under calculus. Actually we have spoke about that in the previous one only. So this integration speaks about big changes, guys. What are big changes? Or you can also say average values. If you want an average value, sorry, that average, the spelling is completely wrong. Okay, average values. If you want the average value for anything, you have to do integration. Integration means, literal meaning of integration is to sum up. Okay, sum up or summation. Yes, today I have to check my mic since it is a little bit low charging, so that is why I'm checking it. Summation. Okay guys, integration means getting all the small things together. Integrate. Okay, integrate. If you have seen in 10th class, like while I was in my 10th class, that was year of pass, mine was 2021. Yeah, at that time, at the COVID time, 2020 actually, during this COVID time, CBSE board has announced some integrated projects, right? Integrated projects have to be done. Yeah. So as per that, if you take integrated, meaning is you have to include each and every subject into it. If you have to make a project in which it has to include biology, in which it has to include physics, chemistry, or maths, if you have it, if you have English, you have to include. So all this, that is the integrated project. It was given separately for groups and separately for languages. Okay, that is the meaning of integration. So that is why I have took this one in order to explain you the meaning of integration, guys. Okay, just leave it. So integration means summation or to sum up. Okay, it is simple. It is the converse of differentiation. What is it? It is a converse of differentiation. Actually in differentiation, what we have done yesterday, if we have a big thing, we have divided it into small pieces, and we have studied the properties of this small piece yesterday or in the previous thing. But now what we do is, we have this small one with us. We do not have this whole big one, but we have this small one with us, and now we study the properties of this small one. Okay, we study the properties of this small piece, and what we do is, we join these small pieces, now n number of small pieces into a big piece. And interestingly, as I said yesterday, the properties of this small piece only will be repeating themselves all throughout this big thing. Okay, that is what. In differentiation, we have a big line, we have divided it, and we have studied the properties of one piece. But in today's episode, we will be discussing the properties of one piece, and we will be adding up to get an infinite long thing. Okay, that is integration, guys. So it is a converse of differentiation. How did we represent the differentiation yesterday? We have represented it like this. The general equation also today I am taking, that is y is equals to f of x. We have represented this equation as dy by dx, right? Independent variable by dependent variable. Am I right? Yesterday, if you haven't seen yesterday's episode, go fast and see it. Okay, not go fast, but you have to see it, guys. Okay, you have to see it. We have represented like this: dy by dx. Am I right? Y is dependent upon x. We have represented, this is differentiation representation. But in today's episode, we are talking about integration, so we have to have some change. So what we are doing is, we are putting this one. Okay. Oh, sorry, a mistake. We are doing it like this. Okay. Okay, let us take this general equation as since I have written the equations as per this general equation and this integration, so again I have to change all those. So take this general equation as this: x is equals to f of x, and this also changes here. This also changes as dx by dy, and this changes as integration of x with respect to y. Got it? This is the representation. Okay, guys, clear? Are we good to go? This is the representation of integration. Notation, you can say. Notation. It is a notation. See this. This is the s. Okay, you all know s, right? So just pull it up this way and this way, upward and downward, you get this. This means summation. But in some chapters we will be coming across, like in magnetic field chapter, we will be coming across like this. So this is called integration towards that closed loop. Integration of that closed loop. We get like this: closed integration of B dot dl. We get it in our magnetic field chapter. Okay, so that is called as closed integration, or integration of a closed loop. Okay, that one let us put it aside. Concentrate on this only. Concentrate on this notation only. When that comes, I will be teaching you there. Okay, this is the integration. Now let us move. Let us dive deep into this. Let us dive little deep into this. Are we good to go? Yeah. Are we good to go? Yeah. Okay. If you are understanding, it is well and good. If not, you can mention in the comment section below. I'll be solving and taking up your doubts. Okay. That is your integration. Now let me say you the meaning of this. We have represented it like this, right? This means integration of x with respect to y. So, or you can also say it as integration. I have already told you in the previous episode, that we always integrate or differentiate dependent variable with respect to independent variable. Am I right? Dependent variable with respect to independent variable, and this is our equation which we have taken today. Here, what is the dependent variable? X is the dependent variable. What is the independent variable? Y is the independent variable. Am I right or wrong? Yeah, I have explained you about this dependent and independent variables in the previous session. But no problem, if you haven't seen, I'll be just revising it now. Let us see. From our 8th or 9th classes, we write equations like this is equals to some 5. We write equations like this. So what we have to do, we have to plot a graph. For finding, we have to plot a graph by finding the values of x and y. Am I right or wrong? So what I do is I want to find x. Yeah, I want to find x from this equation. What I do is I take this one there, so x will come out to be 5y minus 5 by 2. Am I right or wrong? Am I right? Am I right or wrong? Now what I do is I do a table like this. I put a table like this. What I do, so I want to find the values of x, so I can put any input in the y. I can put any input in the y. So what I do is I put y1, so it will come 0. X is 0. Am I right? Am I right? If I put 2, x will come out to be 5 by 2. If it is 2, x will come out to be 5 by 2. If it is 3, it is coming out to be 5. Yeah, x is coming out to be 5. So what is happening here? I am fixing the value of y. I am putting the value of y input. I am giving you the input of y, but the output is coming as a value of x. Yeah, value of x is coming while depending upon y. As the value of y is changing, value of x is changing. Value of x is also changing as the value of y is changing. Am I right? Am I right? I'm taking y as my wish, but value of x is coming depending upon that value of y, which I have taken. If I take 1, it is 0. If I take 2, it is 5 by 2. If I take 3, it is 5. So like that it is coming out. So here you can say that y is the independent variable. This y is not depending upon anything else in the equation except my wish. Yeah, this is not depending. It is not depending upon anything in the equation, upon any other variable in the equation. It is ignoring the presence of other variables, and it is the taking the values which I am providing it. Am I right? But this x, it is depending upon the other variable y. It is depending upon, its value is being depending upon the variable y. So that is why it is called dependent variable and it is called independent variable. Am I right or wrong? Am I right or wrong? Are we good to go? Are we good to go? Yeah. It is always, if you take differentiation or if you take integration, we always integrate or differentiate dependent variable with respect to independent variable. Am I right? Similarly, we are finding the values of what? We are finding the values of dependent variable with respect to independent variable only, Here, we are not finding the values of independent variable with respect to dependent. That cannot be possible. You have to either write the equation other way. If it is a equation like this, you do not want to find the value of x, but you want to find the value of y. You want to fix the value of x yourself. So what you do is you take this 2x that way. So y becomes 5 minus 2x by 5, and now what you do, you fix the values of x and you find y. Now here y becomes dependent, x becomes independent. As you wish, as you change the equation, as you change the solutions, the dependent and independent variables change. So that is why you always integrate or differentiate a dependent variable with respect to independent variable. Am I clear? Am I clear? Are we good to go? Are we good to go? Yes. No. Let us dive straight into the basic formula. Some basic formulas. Yes. Basic formulas. Yeah. I'll be changing the backgrounds in the further episodes also. No need to worry. Here I have many other backgrounds. Can I show you? See, this is one. See, I'll be choosing cool backgrounds and changing it in order to provide you a very good interactive lecture. Always you will also be bored to see the same green board, right? So that is what. Wait a minute, guys. Wait a minute. So yes, guys, yesterday we have got some 11 basic formulae, but in today's episode we will be only having just some 6 basic formulae, guys. not 6 also, 5 only. Okay, 5 to 6, 6, you can take 6. Okay, 6 basic. Let us start with the very first basic formula. In the previous episode we have discussed that if it is x to the power n, it will become n x to the power n minus 1, right? So similarly our equation is y is equals to f of x, right? Similarly, okay, I'm changing the equation from x is equals to f of x to x is equals to f of y to y is equals to f of x. Okay, this is our very prone equation, so that I can discuss this also, the differentiation also parallelly. Now if it is integration for this equation, it becomes integration of y dx becomes, okay, wait, I have to give you the form, right? So if it is in the form of x to the power n, then if you integrate this, with respect to the variable, if you integrate this with respect to the independent variable, you get x to the power n plus 1 by n plus 1. What you have to do here? You have to do nothing. You have to just increase the power by 1 and divide it by the increment in power. That's it. You get the answer. Okay, let us try some questions. Let us try to do some questions. First one I will be doing for you. Next you have to solve. If it is x square, then what it becomes? X to the power 2 plus 1 by 2 plus 1. Okay, it becomes x cube by 3. Got it? If it is x cube only, tell me the value. It becomes this. If it is x to the power 7, okay, take 7. If it is x to the power 7, then it becomes, come on, fast, simple. You have to just increase the power by 1 and divide it by the increased power. Okay, that is the thing. Now let us move on to the next basic formula. Second basic formula is this. If it is in the form of x to the power minus 1, yes, in the previous episode, if you remember, I have told you that differentiation of ln x gives you 1 by x, which means ln x ka differentiation to x to the power minus 1. Now I have also told you that in today's episode, integration is a converse of differentiation. So if you are differentiating ln x, you are getting x to the power minus 1. But if you integrate this x to the power minus 1, you get ln x. You get it, ln x. Am I right or wrong? Yeah, you get ln x. Since integration is a converse of differentiation, right? Integration itself is a converse of differentiation. So that is why you get here. Okay, you also write it as ln is a natural logarithm, so log x to the base e. This one also you can write it as. Okay, let us solve some questions. Now. X to the power minus 2 gives you ln 2. X to the power minus 3 gives you ln 3. X to the power minus 7 gives you ln 7. X to the power okay, ln 3, and if it is x to the power minus half means x is written like this. Okay, then it gives you ln minus half. Okay, ln minus half. This is just a small question, but do not remember this. Logarithmic values I'll be discussing. Okay, no problem. Okay, do not worry, do not get tensed. I'll be discussing in the next episode itself logarithmic values. Next episode I'll be discussing the trigonometry and logarithmic values. Then we'll be completing our basic mathematics. Then we can move on to the vectors part. Okay, clear. Let us move on to the third one. So until now we have discussed two equations here. What are they? First one, if it is in the form of x to the power n, then you have to increase the power by 1 and you have to divide the whole thing by incremented power. Next one, you have also seen that if it is in x to the power minus 1, if it is in that form, you represent it like this, ln x. Okay, okay, ln x. That's it. Now let us come to the third equation. This remains the same. This e to the power x remains the same. Okay, now let's move on to the fourth one. Cos x, integration of cos x. This sin x, very simple, very simple. I have told you that differentiation of sin x is cos x. Integration is a converse of it. Integration is a converse of it. So then what happens? Then what happens? Sin x becomes minus cos x. Here you are getting in differentiation. In differentiation, the integration of sin x is plus cos x. But integration is a converse of it. So you have to put a minus sign before it. But we have also discussed that in differentiation, cos x ka differentiation is derivative is minus of sin x. It is integration here, so you get plus sin x. Okay, very clear, very clear. Okay, let us move on. Let us move on to the last thing. You can also actually represent this as represent it as you can also represent it as integration of minus sin x dx. You can also represent it like this, no problem, no problem. Okay, let us move on to the last thing. Last thing, if it is like this, then it comes x. Okay guys, these are the very 6 basic formulas that you have to remember in integration, while doing integration, while performing integration. Let me put, okay, I expected it, but I thought everything would come. Wait. Let me put everything on one side so that you can take a screenshot or slingshot, or you can also practice and prepare now it itself. Okay, take a screenshot or you prepare it now. Prepare these 6 formulae now. Prepare these 6 formulae now. Now until now I haven't taught you something, that we have to put an integration constant c everywhere. I'll be discussing it a bit later. After this, in the next slide, I'll be talking about the c. What is the importance of this c? We will be discussing in the next slide. Okay, okay guys. Now did you revise these 6 formulas? Just revise these 6 formulas. We will be moving on. Revise these 6 formulas. We will be moving on. Yeah, have you done? Have you done? Putting what is this integration constant now? What is this integration constant doing here called c? Now, we are talking about integrated constant. Okay. For discussing this, you have to learn the types of integration. Sorry, I thought it is a green board, so that would, yeah, types of integration. See guys, if you want this note, so I'll be writing it neatly. If you don't want this, there is no point in writing it neatly and wasting your time, right? So that is why I'm writing it in an order. So not in an order. I am writing it as we write on the whiteboard there. Okay, same way I am writing it here. If you want the notes, please let me know. I'll be writing it neatly, and I'll be sharing you this lecture notes also. Okay, okay. Let us discuss this types of integration now. After this, we'll be moving on to the examples. Okay, examples. Yes, types of integration. We have actually 2 types of integration. One is a definite, called as definite integration. and the second one called as indefinite integration. Definite and indefinite integrations. These are the two types of integrations that we have actually. So what is definite integration? What is indefinite integration? See, let us try to understand the literal meaning of these. Okay, definite, limited, definite. We have definite quantity of eggs, or we have definite quantity of pages. We have limited quantity of eggs, or we have limited quantity of pages. Okay, do not mind when I am seeing it down, since the reflection of this light is seen in my tab, so that is why I'm seeing it. If it blinking red, I have to stop the video, since the charging is low, so that is why. Okay, never mind, let us try to complete the lecture before the charging ends. Okay, a limited number of eggs, limited number of pages. Definite means limited, you have been limited to that particular thing, you have been limited to that particular thing, you have to not cross the limits, you have to not cross the limits. You have definite shape, you have solids of definite shape, means what? They have this territory out of which they have to not cross, they will not cross out of this territory. This is the territory, and that is definite. They have definite shape, means they will not flow like fluids, they will not occupy the other territories, they will be remaining in their territory itself. Okay, that is definite meaning. But indefinite, infinite, you don't have any limits, you don't have any limits, you can cross your limits like fluids. See, if yeah, if you are in a college, or if you are in a school, okay, if you are in a school, in school you have teacher on one side, class teacher on one side, you have a subject teacher on one side, you have a principal, vice principal, dean, etc, etc, it goes on like that. But let us consider only a class teacher, okay, not class teacher, let us consider only a subject teacher, particular subject teacher, and a vice principal or a coordinator for that floor. Okay, we are considering a coordinator and a school subject teacher for this example. Now, you are in this class, you don't like this subject, you do not like this subject, okay, you do not like this subject, you have to move out, you have to move out. Now, for moving out, how many people you have to cross? You have to cross both the coordinator and subject teacher. You have to first cross the subject teacher, then the coordinator. So you have been limited, you have been limited, you have been defined into the class. You cannot cross them, you cannot go anywhere. You have been limited in your applied pressure, peer pressure, and you have to listen this subject. It is a must and should. Since you cannot cross the subject teacher, you cannot cross the coordinator. But assume only this. It is an assumption only. This does not happen. This does not happen. So I'm not. This fellow is not there. Okay. Okay. Coordinator is not there. Subject teacher is also not there. No one is there. Coordinator outside, coordinator is also not there, and inside the class subject teacher is not there. Now, who are there to stop you? You can just freely move out of the class. You have no limits. You have no limits. Yeah, you have no limits. You can move out, you can come in anywhere, anytime, any place. Okay, you can go there, you can roam, you can come in, you can sit in the class. If you are bored, you can go out. So like that, you have no limits, no limits, you have been indefinite. So that is the meaning of this. So if you have limits, you are definite. If you don't have limits, you are indefinite. So integration also, if integration that we are doing has limits, limits exist, limits do exist to the integration, then it is called definite. If limits are absent, if limits do not exist to the integration, then it is indefinite. You can go on integrating it. C is absent if limits are present. If integration is definite, the constant, integration constant is absent. But if it is indefinite, integration constant is present. Either of the thing is absent. Okay, either limits is absent or C is absent. Clear? Limits is absent or C is absent. You have to understand the meaning. Now, what are these limits? First of all, yeah, on the notation I have told you this one. You have to stretch the s on both the topwards and bottom downwards. You have to stretch it. So if I put a subject teacher and a class and a coordinator, these become the limits. Coordinator and subject teacher are your limits, right? Subject teacher is your lower limit. She is present in the class itself. She is your lower limit, but the coordinator is the upper limit. He is present outside the class. Outside the class, how re baba, how you can cross him? So he is the upper limit. You cannot cross the upper limit. You have to go from lower limit to upper limit. Okay, you cannot cross. You have limits on your head and also your legs, both. So this is called as definite integration. If you find any numbers on the top and bottom of the elongated s, it is undoubtedly the definite integration. But if you don't find anything, you have only a plain s and plus c, then it is an indefinite integration. Okay, all these things which we have written here with a c, these all are indefinite integrations. They do not have limits. We only put it like this. We only put it like this. No limits, no limits, no limits. Okay, no limits, not at all. Okay, okay, now, okay, these are the things. Are we good to solve some examples? Are we good to solve some examples in the indefinite thing? Then let us move on to the definite integration. Okay, let us solve some examples in the indefinite integration. Then we will be moving on to the definite integration. Okay, let us start. If y is equals to x square plus x to the power minus 2 plus 3 e to the power x dx. Solve for integration now. Solve for integration fast. Find this integral y dx. Find this integral y dx. Very simple, very simple. Like yesterday only, like in differentiation only. If it is there is a coefficient in if there is a coefficient while you are integrating, just slip it out, just bring it out of the integration and integrate the rest part. Okay, let us are you ready for solving this? Yes. If you want to differentiate, I'll be doing both. Okay, for the people who haven't seen yesterday's episode, I'll be doing differentiation, and for the people who have seen that and who are seeing this episode, I'll be doing the integration. Okay, but integration itself is our episode today. No, okay, but I'm doing differentiation and integration, since you have to not face any problem while doing it. Differentiation, practice makes man perfect. Just do differentiation and integration both. Okay, find dy by dx and also integral y dx, both. Okay, then writing this differentiation and integration, I can put this, right? Simply I'll be putting it. Wait, find dy by dx and also integral y dx, both. Okay, first let us find dy by dx, then we'll be moving on to integral y dx. For finding dy by dx, we have to move on to the formula of differentiation. So what is the general formula of differentiation? First basic formula, x to the power n becomes x to the power n minus 1 and nx to the power n minus 1. So it is x square 2x plus okay, minus comes here, yeah, minus 2 x to the power minus 3. Okay, we have done it yesterday, right? We have done this. Do you remember it? Yeah. Now it is a coefficient. It slips out of the differentiation and integration both, but you have ex remains the same in both integration and differentiation. So this is your differential product. Now for the integration, you have to increase the power by 1 and divide it by the integral power. Now it becomes x cube. It is x square, right? X square means x to the power 2 plus 1 by 2 plus 1. X to the power 3 by 3. Now, if it is x to the power minus 2, it is x to the power minus 2. Then what it becomes? X to the power minus 2 plus 1 by minus 2 plus 1. Right? Now what it becomes? Next one. It also slips out of the integration part and it is ex. So it remains the same. So now it becomes x cube by 3 plus, okay, minus, it becomes minus again. Why? I will be telling you. See, okay, right, plus only. Now it is minus on the top, minus 1 on the top and minus 1 on the bottom. This minus shift to the numerator and this comes to the denominator. Then what happens to this? Minus 1 by x plus 3e to the power x. This is the integral product. This is the product after integration. Since it is an indefinite integration, you put c. There are no limits, so you put c. No limits, you put c. Okay? Okay? Clear? 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 Now I'll be giving you a small thing again, small equation. Solve for this. X is equals to this one plus sorry, y is equals to this. Solve. Find the integration of this now. First, find the integration of find y integral y dx. First, come on, fast. Let's do it together. Let's do it together. First you have to do integration of this. So it becomes very simple, right? What it becomes? 2 3 by 2 x to the power 3 by 2 by 3 by 2. Okay, very simple. Write the direct steps. X to the power 3 by 2 by 3 by 2. No problem. Leave it like that. Leave it like that. Okay, no, not hesitate and worry. Now it becomes 5 means you get a you get here 5 x to the power minus half plus 1 by minus half plus 1. Yeah, plus it becomes 6x to the power 8 by 8. This becomes 3 by 4 plus 0. Integration of 10 is also 0. Since there is no change in the constant, so you remain at 0. So that is why what it becomes, x to the power 3 by 2 by 3 by 2 plus okay, not plus, let us put minus directly. Oh, it comes plus only, not minus. Yeah, it comes plus. Plus 5x to the power 1 by 2 by 1 by 2 plus 3 by 4 x to the power 8. This is your integral product. This is your result of integration. Okay, I'll be giving you one last. You have to put c here. You have to put plus c here. Okay, one last one. Y is equals to x to the power 7, 8x to the power 7 plus 9x to the power 8 plus 10x plus 7. Find the integral product of this. Okay, find the integral product of this. Find integral y dx. First, come on, let's try to do it together. 8x to the power 8 by 8, it is 8 x to the power 8 plus 9x to the power 9 by 9. Yeah, it is x to the power 9 plus 10. Yeah, plus 10 plus 0. Right? Okay, are you good? Yeah, how it does come 10? So it comes like this, right? Integral 10 x dx, 10x dx. This is what? This is a coefficient that slips out of the integration. So it comes integral x dx, yeah, x dx, integral x dx is what? You have to integrate this, just integrate it. How can you integrate? X square, yeah, x square by 2, sorry, this comes like this, sorry, I'm really sorry, it comes 5x square. Okay, x to the power 8 plus 9, 9 to the power x, sorry, x to the power 9 plus 5x square, okay, plus c. This is the thing. Are we good to go? Are we clear with this concept? Are you clear with this indefinite integrations? Are you good? See, you give yourself own equations and practice, practice, practice. Now you will be finding integration so easy. You will be finding differentiation so easy. You can give any equation, I'll be differentiating it. You can give any equation, I'll be integrating it. Be like that. Be like that. Very quick. I'll be making you like that. Okay. After this, let us talk about some definite integrations. But for definite integration, limits are there. Of course, we will be setting the limits from 0 to 2. Okay. We will be setting it like that, and I'll be giving you a small example and then explaining it. If it is like this, okay, let us choose not 0 to 2. I have written an example of this from -1 to +1. Okay, let us choose this. Let us choose this. Okay, now first what you have to do, for as if you have to do it as if you do not have these limits with you. You do not have these limits with you. Do it like that. First of all, integrate it as a normal equation only. After integrating, what you get? After integration, what you get? Thus, after integrating, you get x square by 2. Just now we have did it, x square by 2, x square by 2. Now put these limits. Now put these limits. Oh, sorry. Now put these limits. Now put these limits to the square brackets like this. Now what you have to do? You have to put this in your mind. Upper limit minus lower limit by 2. Put this in your mind. Okay? Okay. Now upper limit square minus lower limit square by 2. This you have to put in mind. So yes, guys, I told you, no, anytime, any moment, the charging of the mic might get discharged. So that is the moment. I don't know at which moment that happened. So that is why what I'm doing is I'm just revising it from here, from this one, yeah, from this slide. I was looking at this from until the 8th slide, but from the 9th slide I have doubt. So from this point I'm repeating it. Please listen by carefully. See, if it is given, if it is mentioned that limits are mentioned, if limits are mentioned, what you have to do is, I told you that you have to integrate it as a normal equation and then substitute the limits one by one and subtract them like this. So what you have to do, you have to first substitute the upper limit, you have to square it, and then you have to substitute the lower limit, you have to square it, and you have to find the difference between them, and you have to divide by 2. Simple it is. This is how simple it is. See, if it is limits are given, you have to first integrate it as a normal equation, then you have to place the limits for the square brackets, then you have to do the square of upper limit, then you have to do the square of lower limit and subtract them and divide it by 2. After that you will be finding your the integration result. Now next one, I have given you this equation, right? I have given you this one. From this I'll be doing it again. Okay, I'll be doing it again. First I said you integrate it as a normal equation. X cube, if x cube is there, it is the integration product, right? If x square is there, this is the integration product, right? If it's 10x, we have done it just now. If it is this, if it is 10, it is 0. So let us remove 0 to 10. Let us remove 0. Now what you have to do, put square brackets each. Okay, put square brackets for these each put square brackets. I have given you limits from 0 to 2, so put it 0 to 2, 0 to 2, 0 to 2. Now what you have to do, you have to substitute upper limit first substitute upper limit in place of x. Wherever you find the variable alone, substitute upper limit first and square it. Okay, first substitute upper limit a square and then minus, sorry, first substitute upper limit, then substitute lower limit, square it and minus it by 2. Yeah, and then substitute to lower limit, it is 0, so put it 0, then it becomes 2 to the power 4. Here you have already 4. Okay, you have 4 here, you have to substitute it 4 also by 4. Okay, this is what, minus 0 by 4. Okay, plus same way similarly substitute it like this here also, 2 cube. Okay, okay, 2 cube whole square, do it this way. Okay, here also do it this way, 2 to the power 4 whole square by 3. Here also the same way, 5 into 2 a square, and then you go with an whole square. This is not a full bracket here. The square is not for a full bracket, but it is for only the x. Okay, here it is only x, so it is full bracket. Here it is only for the x, only for the x. Now solve this, you will be getting your answer as, so 2 to the power 6, 2 to the power 6 by 2 by 4 plus this one is 4 into 2 to the power 6 by 3 plus 5 into 2 to the power 4 by nothing, by nothing. Okay, that is your answer, that is your integral product. If you solve this, you will be getting your integral product. Now let us apply this in kinematics. Yesterday I have told you from position, if you have the change in position, rate of change of position is your velocity. If you have velocity, you can find acceleration, you have to differentiate for that. But if you do the converse of it, you will be getting the integration, right? If you have acceleration, you have to find velocity, you integrate. If you have velocity, you need to find position, you integrate. But you will not get the position, You will never get the position. You will be getting the change in position if you integrate. You will be getting change in velocity if you integrate. Okay, similarly you will be getting a small change in velocity, you will be getting small change in acceleration when you differentiate. Okay, this is the thing which is applied in the kinematics. Okay, this is how we have to apply in the kinematics. Okay, okay, wait a minute. Here what we did actually is, wait a minute, just wait a minute guys. It is just 2 again, y2 square it, that's it. Sorry guys, sorry, really sorry, I'm really sorry, I'm really sorry this time, since I have done a small mistake here. The thing is, the thing is 0 to 2, 0 to 2, 0 to 2 limits are, you have to just substitute the upper limit and square it, right? Yeah, it is upper limit ka square minus lower limit ka square by 2, or it is only this one? Not getting that. Wait a minute guys, it is upper, not square guys, sorry, I'm sorry, I'm literally sorry for the square, not square, it is only this one. Okay, put it like this, then it becomes 2, you put substitute 2, 2 to the power 4 by 4 plus 4 into 2 to the power 3 by 3 plus 5 into 2 to square, 2 square. Okay, just remember it. I'll be clarifying you this in the next episode guys, just wait and watch, just wait and watch, I'll be clarifying it in the next episode. Okay, now this is your kinematics application. Okay, kinematics application, clear, clear. Now are we good to go? Are we good to go? I'll be discussing you the Newton's second law. In the previous episode, I have already told you about Newton's second law. Yes, I guess I have already told you about the Newton's second law. What is Newton's second law? The rate of change of the time rate of change of linear momentum gives you force. Similarly, if it is the time rate of, I have already told you, I have already taught you that this is force. Similarly, if it is the same integration gives you momentum, it is the integration of force that gives you momentum. So that is your Newton's second law application. Okay, clear guys, clear, clear. Yeah, I'll be giving you one question. I'll be giving you one question. Let us solve it from the kinematic. So guys, it is not a square, it is just upper limit minus lower limit by 2. Okay, no need a square, no need a square, no need a square. Sorry, I'm really sorry. So now let us solve a question from the kinematics. I'm reading out the question like yesterday. I'll be writing the equations on the board. Okay, are we good to go? Yeah, the last question we'll be solving and we will be moving on. Okay, we'll be going. Last two questions. If the velocity of a particle is v is equals to bt square minus at, where b and a and b are constant, then the distance traveled by it, they are asking the distance traveled in 1 second to 2 seconds. They have given you limits, they have given you limits, you have to substitute the limits. Come on fast. For finding, if we have velocity, for finding the displacement, change in position is the displacement, so that is what we have to find. For finding the change in position, what you have to do, you have to integrate velocity, you have to integrate velocity. Now and find the integration of this, find the integral v dt. You'll be getting as so this v dt, integral v dt will be equals to your change in position, which is equals to distance travel, which will be it comes from, you have to do it limits from 1 to 2, you have to do it with limits. Now first it will become this one, right? It will become this one, right? Now apply the limits, from 1 to 2, apply the limits from 1 to 2. It becomes, substitute 2 here, it becomes 8b by 3 minus Substitute 1 here, it becomes b by 3, yeah, whole minus this one. Substitute 2 here, it becomes 4a by 2, it becomes 2a, minus you substitute 1 here, it becomes a by 2, yeah, it is 4a by 2, it is a by 2. Okay, now this becomes 7b by 3, 7b by 3, minus this becomes 4a means 3a by 2, 3 by 2a. Simple, simple, very simple, right? That is your integration product, and this is the distance traveled. This is the distance traveled. Okay, now last question of the day. We will be ending up this here. We will be ending up this here. Come on. The acceleration of the particle is increasing linearly with time t as bt. Acceleration is equals to bt. The particle starts from origin with initial velocity. Initial velocity v is a v. Initial velocity is equals to v naught. Okay, the distance traveled by particle in t seconds will be, okay, from 0 to 2, from 0 to t will be the distance you have to find. Now we know that acceleration is equals to differentiation of velocity with respect to time. The rate of change of velocity is acceleration. So take this dt here, then what happens? Dv is equals to a dt. Integrate it on both sides. You will be getting velocity. I have told you this. I have told you that if it is x. So from that it is velocity, and if you integrate this, now what is acceleration? It is bt. It becomes bt dt integral of. So v will be bt square by 2. Okay, velocity will be bt square by 2. But you have to integrate it. You have to integrate it with this one. You have to integrate it with what? You have to integrate with these, what do you call, limits, from v naught to v, yeah, from this also from v naught to v. Okay, this becomes now, if you have to integrate it with limits, it becomes what? V bar minus v naught bar is equals to bt, bt, okay, bt. This one you have to from t to 0 to t, 0 to t, then it comes bt, bt, it comes bt if you solve that. So now v bar is equals to bt plus v naught bar, v naught only, simply, okay, v naught, bt plus v naught. Now differentiation of velocity, okay, or simply velocity is equals to dx by dt. Rate of change of position with respect to time is velocity, that is equals to bt plus v naught. Now if you just integrate it with limits, you will be getting the position, right? You will be getting the this one, distance covered. So integrated with positions, integrated with limits from 0 to t. Now this becomes x is equals to bt square by 2 plus v naught dt, right? dt from 0 to t. Okay, not dt from 0 to t. So on integration, this d gets away, this d gets away. So t from 0 to t. Now put a t, it becomes a bt square by 2 minus 0. Okay, put it like this, plus a v naught t, and this is your distance traveled. That is your distance travel. That is your final distance which you get. Okay, clear guys? Clear? Once again, I'll be explaining you this problem. Just look at it. Just take a look at it. We have given that velocity. We have been given velocity is equals to bt. Is it that? Sorry, not this one, this one, right? Yeah, it is different. Yeah, we have been given that. Wait a minute, I'll be writing you. We have been given that velocity is equal to bt. Is it velocity? No, acceleration. Yeah, no problem, guys. we have been given that acceleration is equals to bt, a bar is equals to bt, but we know that acceleration is rate of change of velocity, which is equals to bt, right? Right. Now what I'm doing is I'm sending that bt there, dt there, it becomes bt dt, bt dt. Okay, now then we have to integrate it from v naught to v, and we have to integrate this from 0 to t. Okay, now it becomes v minus v naught is equals to this one, bt, right? Now this becomes v is equals to bt plus v naught, bt plus v naught. But we know that velocity is a dx by dt. This is equals to this plus this, and if you send that dt there, will become dt. Now integrate this with respect to from 0 to t. Integrate this from 0 to t. Then x is equals to, not this one, sorry. Integrate this on both sides from 0 to t. Then it becomes uh, bt square by 2 my plus a v. That will be your answer. Fine. Fine guys, I have also covered the topic of differentiation in this, the topic and application of differentiation uh, in this problem. Application of kinematics, application of differentiation and kinematics I have covered in this problem. I have covered differentiation also today. I have covered integration also today. Likewise, we will be covering the trigonometry and also the what you call the logarithms in the next episode, guys. So this is Vamsi signing off from Insane Physics. So have you a great day further, guys. Thanks for watching. Bye bye.